Dear children, on behalf of St. Paul's Convent High School, I extend a warm welcome to you children to this offline session. This is class 9th physics describing motion. In our previous sessions, we have discussed some of the concepts like motion, the types of motion, examples of those, distance, displacement, speed, velocity, etc. Children, quickly we will revise what has been done in our previous sessions. To begin with, the definition of motion. Change of position of objects with time is known as motion. Then examples for different types of motions. Examples, rectilinear propagation, or vibratory or rotatory, oscillatory motion, etc. Then uniform and non-uniform motion. Uniform motion, if an object covers equal distances in equal intervals of time, then we say it is in uniform motion. If an object covers unequal distances in equal intervals of time, then we call that as non-uniform motion. Physical quantities, quantities which can be measured are called as physical quantities that can be categorized into two. One is scalar and another is vector. Scalar quantities, quantities which have only magnitude but no direction. Examples are given children. Vector quantities, quantities which have both magnitude and directions are called vector quantities. Then distance. The total length of the actual path traveled by the body from initial point to final point is considered as the distance. SI unit is meter children. Displacement, it is the shortest distance from initial point to final point. We call that as displacement. Its SI unit is also same meter children. The difference between distance and displacement, at least three you must learn children. There is a device called odometer which measures the distance traveled by the body. There is a device called speedometer which measures the speed of the vehicle. Speed, we have seen in our previous session children. This can be calculated. The distance traveled by the body divided by time taken. This is the formula we use. What may be the distance traveled by the body? The distance covered may be 500 kilometers. Total time taken may be 8 hours. So 500 divided by 8, we get the speed of the vehicle. The SI unit is meter per second children. It's a scalar quantity because it doesn't have any direction children. Uniform speed, this is very similar to uniform motion children. If an object travels equal distances in equal intervals of time, then it is in uniform speed. If an object covers unequal distances in equal intervals of time, then it is in non-uniform speed. Average speed children. Consider types of journey is not uniform on children. When there is a rush in the road or when there is a traffic jam, a vehicle will go very slow. Speed becomes slow. When there are nobody on the road, think of an highway, speed varies. Speed reaches the maximum. Therefore, how average speed is calculated? It is calculated what is the total distance traveled by the object and total distance. So total distance traveled divided by total time taken, we get average time children. The ratio of total distance traveled by the body to the total time taken is called average speed. Average speed is calculated when the speed is not constant. It can be calculated mathematically. Average speed is equal to total distance traveled It may be 500 kilometers divided by total time taken 8 hours. Okay, therefore 100 kilometers per hour. When an object moves in non-uniform motion, then average speed is calculated. There is a concept, children, which tells us speed with direction. Speed has no direction. If speed has a direction, then we say it is velocity. It is another term, children, velocity. It can be calculated. The displacement of a body in unit time is called velocity. Mathematically, it is calculated. Velocity is equal to displacement by time taken. Displacement, regarding this, we have seen in a previous concept, children. Displacement. The shortest distance between the initial point and the final point is known as displacement. It is a vector quantity, we say, because velocity has direction, children. See, there is a concept which tells us speed with direction. If the speed has direction, then it is velocity. Therefore, it is vector quantity, children. Let's differentiate between speed and velocity. First, I have taken the definition itself, children. It is the distance traveled by the body. It is the displacement of a body in unit time. It is scalar. It is vector. Which has no direction, children. This has direction. Uniform velocity. If a body covers equal displacements in equal intervals of time, then it is in uniform velocity. Uniform speed, we have seen, children. That's if an object covers equal distances in equal intervals of time. There we have used distances, children. Here we use displacements. That is, the distance traveled, equal distances in a particular direction. I have given, children. Non-uniform velocity. If a body covers unequal displacements, that is, unequal distances in a particular direction. Direction to be mentioned because it's velocity. If a body covers unequal displacements in equal intervals of time, then it is called non-uniform velocity. Average velocity. Average velocity can be calculated in two ways, children. One is the displacement by time taken. Average velocity can be calculated. Average velocity is equal to displacement by time taken. Average velocity is equal to displacement is S, children, divided by T. This is one formula which is used to calculate average velocity. The second one is when the object changes its velocity from initial to final velocity, we have another formula to calculate average velocity is equal to initial velocity plus final velocity divided by 2. We call this is the arithmetic mean of initial velocity and final velocity. U refers to initial velocity, that is, when a vehicle begins to move, that's the velocity. When the vehicle reaches its maximum velocity, we call that velocity as final velocity. Therefore, the mean of these two, average of two, initial velocity plus final velocity divided by 2, this is the second formula. So, this is what I have given. Average velocity is equal to displacement by time taken. The ratio of total displacement of a body to the total time taken is called average velocity. Mathematically, this can be given, children. Average velocity is equal to total displacement divided by total time taken. This is what I have written here, children. Displacement by total time taken. The second is or the arithmetic mean of, which means an average of initial and final velocity of the body is called average velocity. That's what I have given here, children. Average velocity can also be calculated initial velocity plus final velocity divided by 2. This is the mathematical representation, children. Average velocity is equal to initial velocity plus final velocity divided by 2. Average velocity is equal to u plus v divided by 2. You have to write it here, children. Regarding acceleration, children, this is another new term to you, dear children. Acceleration. Our velocity is not the same throughout our journey. When the velocity changes, a body moves in a straight road, okay? If the vehicle changes the direction, velocity changes. When the velocity changes, children, acceleration takes place. Therefore, when there is change in the velocity, during the start movement of a vehicle, the velocity of the vehicle must be 0. Initial velocity is 0. It reaches the highway, it reaches the maximum velocity. We call that as final velocity. Therefore, velocity changes. When there is change in velocity, children, acceleration exists. Okay? Therefore, how do we define the word acceleration? Acceleration is defined as the rate of change of velocity is called acceleration. Acceleration, this is the definition part, children. In one word statement, this can be given. Acceleration is equal to rate of change of velocity. This statement further can be written mathematically. Rate of change of means numerator by denominator divided by time. Change in velocity by time taken. Velocity changes, change of velocity divided by time taken is rate of change of velocity. Rate of work done you have seen, rate of work done. This can be written as is equal to work done by time taken. Rate of work done, rate of change of velocity divided by time taken, divided by time taken. It's about children. Now, this rate of change of velocity is written like this, children. Change in velocity by time taken. Change in velocity means, children, it might have traveled with a final velocity it starts from initial velocity. Imagine a vehicle moves in a highway, children. It starts from A. At this position, its initial velocity is 0 meter per second, children. Slowly it moves. Then, after 5 seconds of time, it reaches the velocity of 20 meter per second. We call this as final velocity. So, with the help of this, you'll be in a better position to understand this. Velocity changes with time. Previously, its velocity was 0. We call that as initial velocity. Now, its velocity changes to 20 meters per second in a time of just 5 seconds. Therefore, the rate of change of velocity is change in velocity by time taken. How this change in velocity is calculated? Final velocity minus initial velocity divided by time taken. That is acceleration A is equal to final velocity minus initial velocity divided by time taken. This is the mathematical recognition of the formula acceleration part, children. A is equal to V minus U by T. SI unit is meter per second square. In this, we consider meter per second square. Either you can write it in this way or meter second to the power minus 2, children, because it is in the denominator. When it comes to the numerator, the sign of the power changes to minus. It was plus, it became minus. SI unit is meter per second square. Now let's discuss about uniform acceleration with a diagrammatic representation. Children, regarding this uniform acceleration, children, I have taken a diagrammatic representation. This diagram will be in a better position to make you understand, children, this uniform acceleration. Consider an object travels from A to B, B to C, C to D, D to E, and last it reaches F, children, through a straight line. Consider the velocity. Its the velocity is 0. We call that as initial velocity, children. It's represented by small u. Initial velocity is 0 meter per second. After the time interval of 5 seconds, its velocity became 20 meter per second. Then from B to C, again with the time interval of 5 seconds, velocity changes to 40 meter per second. After the 5 seconds, it became 60 meter per second. Velocity changes. See, velocity was 0, then it became 20, 40, 60, 80, 100. Velocity increases by equal amounts in equal intervals of time. See, if an object travels in a straight line and its velocity increases or decreases. I have taken the example of increases here. Velocity increases by equal amounts, that is 0, 20, 40, 60, 80. Okay, in terms of 20 meters per second, it increases by 20 meters per second. If the velocity increases by equal amounts in equal intervals of time, equal intervals of 5 seconds, 5, 5, 5, 5, 5, equal intervals of time, then the acceleration is said to be uniform, children. The example that can be taken is the falling of an object from a height. We call that as free fall. If an object is released from the height of about 100 feet, the object undergoes uniform acceleration. Therefore, children, if an object travels in a straight line and the velocity increases or decreases by equal amounts in equal intervals of time, then we call that as uniform acceleration. Make a pause and write down the notes, children. The example that we can take, children, free fall of an object from a height, a motion of a freely falling object towards the earth, children. Now, there must be two conditions, children, are necessary for uniform acceleration. Which are the two conditions? The first one, the object has to travel in a straight line. Straight line. There must be increase or decrease of velocity by equal amounts. These are the two conditions which are necessary for uniform acceleration, children. Now, let's discuss about another concept called non-uniform acceleration. First, let's look at the diagrammatic representation, children. The object starts from A, then its initial velocity is 0 because the velocity starts from rest, children. Okay, the object starts from rest. Vehicle starts from rest means initial velocity is 0. After 5 seconds, its velocity reaches 10 meters per second. Then after 5 seconds, 40 meters per second. After 5 seconds, 20 meters per second. Velocity increases, velocity decreases, again decreases, again increases, again increases. In this, the interval of time is same, equal intervals of time 5 seconds. But the velocity, the increase or decrease of velocity is not by equal amounts, children. Therefore, if an object travels in a straight line and the velocity increases by unequal amounts, children, unequal amounts in equal intervals of time, then it is called non-uniform acceleration. Okay, only one word changes from the previous one. Okay, if the velocity increases by equal amounts in equal intervals of time, then it is uniform acceleration. If an object the velocity increases by unequal amounts in equal intervals of time, it is known as non-uniform acceleration. Then we see equations of motion, children. Equations of motion. So far, we have come across the terms like initial velocity, this is final velocity, acceleration, time taken, and S is displacement, children. Do not consider this as speed. This is displacement, children. All these letters are combined in the form of equations called equations of motion. These terms are related by set of equations called equations of motion. Equations of motion are valid only if the motion is in a straight line. Second one, motion must be uniformly accelerated. These are the two conditions which are necessary for equations of motion. Okay. Now, children, we will look into the three important equations of motion. The first equation of motion is V is equal to U plus AT. Second is S is equal to UT plus half AT square. Third one is V square is equal to U square plus 2AS. As I explained earlier, children, these terms you have to write down one below other. What is U, what is V, A, T, S and all. One by one you have to write down, children. U refers to initial velocity, V final velocity, A acceleration, T time taken, S refers to displacement. All these terms are related by set of equations called equations of motion. These are the three equations of motion, children. You have to remember these three equations of motion to solve sums easily, children. Let's see one by one how we have derived these equations of motion. To begin with, let me consider the first one, children. We know acceleration is calculated. Acceleration, children, the rate of change of velocity is known as acceleration. Acceleration represented by the letter small e, A is equal to change in velocity, that is final velocity minus initial velocity. This is change in velocity by time taken. The rate of change of velocity is called acceleration. This is the formula which we used to calculate acceleration part. From this, we will be getting the first equation of motion. Let me cross multiply these two, children. A into t by cross multiplication. 80 is nothing but v minus u. Look into this step. One step I have done, just cross multiplication. A into t, 80 is equal to v minus u. Now, let me take entire of RHS towards LHS, LHS towards RHS children. Therefore, v minus u is equal to 80. I have not changed any part children. Just I have reversed the terms. Okay, LHS become RHS, RHS become LHS. Now let me keep V there itself children. V is equal to this minus U gets transposed children. When a term gets transposed, its sign changes, you know. Minus becomes plus U children. This is plus 80. So, this is our first equation of motion. V is equal to u plus at. We know that a is equal to v minus u by t children. This is from acceleration part. Acceleration, I will repeat, the rate of change of velocity. This is change in velocity by time taken. Final velocity minus initial velocity by time taken. Next, cross multiplication a into t, at is equal to v minus u children. Now, I have taken this part towards this side. I have kept v as it is. Transpose this minus u. Minus u, when it comes this side, only one term gets transposed. Then minus u becomes plus u. This is plus ap. This is our first equation of motion. Let's look into the second equation of motion. Children, now we are going to derive or prove how S is equal to ut plus half at square, children. Listen carefully. If you have practiced at least 2 or 3 times, definitely this will become a simple to you, children. Okay, listen. Here, I have taken the average velocity formula, children. We know in our previous concept we have seen average velocity. Average velocity can be calculated 2 ways. The arithmetic mean of the average of initial plus final by 2. Initial velocity plus final velocity by 2. One formula to calculate average velocity. One more formula to calculate average velocity. It was displacement by time taken. Two formula we have taken, remember. Now, those two I have written. We know that average velocity is equal to that, or average velocity is equal to displacement by time taken. See the changes that I make here, children. S is equal to V into T. S is equal to V into T. Average V means V. Average V means just V, children. V into T. By cross multiplication I have taken, children. I hope this step is clear to you. Now, listen carefully. V, this V, I take the support of this V, children. First two formula we have taken, children. Then 1 cross multiplication divided by 1. 1 into S is equal to V into T. After that, for this V, I take the equation from there, children. That V is nothing but U plus V by 2 into this T, children. I hope you have understood. For this V, I have substituted. V is nothing but U plus V by 2. So, this is V into T. Now, children, one more final. U I have kept as it is, children, plus. Do you remember this V from the first equation of motion? V is equal to U plus at. V is equal to U plus at from the first equation of motion. First equation of motion. Therefore, V for this, children, U plus at by 2, children. into t children is equal to, carefully, u plus u is 2u plus 80 into t whole divided by 2 children. Now, this is binomial, this is monomial. Let me multiply these two with this children. This will be equal to, let me do it here children, is equal to 2u into t is 2ut plus 80 into t becomes 80 square whole divided by this 2. I have multiplied this t with these two binomial children. Now, this 2 is common for these two. Therefore, the next step becomes 2ut by 2 plus 80 square by 2. Now, this 2 to get cancelled children. S is equal to this ut plus this is 1 by 2 half a t square. So this is how we get S is equal to ut plus half a t square. This seems to be a lengthy one children. You need not to worry about the proof of this equation children. You need not worry about that. This is for your extra information I have given you. 2-3 times practice it, you will find this is easy one. The reason I have taken to prove this is these three equations of motion, very important one, because lots of sums that we are going to solve based on these three equations of motion. Therefore, I have shown you the proof of these two. The last proof we will see in our next class children. So until then, please go through all the concepts, write down in the notes children, and keep learning it. Be safe at home children, take care of your health and be good. Thank you children.